Hello friends, today we will discuss the diagnosis of the fault wash not happening in fully automatic Godrej washing machine. The customer feedback would be wash is not happening, pulse history is not working, and there is a humming noise in the motor but there is no wash. So there are some questions that we ask the customer for better understanding of this problem. Some of them are: does the pulsator rotate clockwise and anti-clockwise? To understand if the motor is working properly in both the directions. Do you hear the motor noise while operation? To understand whether the motor, belt, capacitor, etc. is faulty. Does the machine work without load? To understand if there is any motor overloading issue. Was there any repair done before this complaint? To understand if there is any workmanship issue. So based on our questions and the answers that we received from the customer, we had listed down some probable defects. They are loose open connections, wrong wiring, problem with the belt tension or the belt is broken, the pulsator is loose or pulsator is defective, it is cracked, there is some voltage problem, capacitor problem, or mechanical assembly defective, inlet valve defective or blocked, heater and sensor defective. These are the various defects that we have listed down and we have segregated them according to electrical, electronic, mechanical, customer usage conditions and environment conditions. Now we will check some parameters on the machine for each of these symptoms one by one. Required tools: combination plier, T-spanner M10, 10 and 11 spanner, Phillips head and flat head screwdriver, multimeter. First we check for open connections, loose connections or the wrong wiring in the washing machine. We check for any rodent bite or whether any wire has been cut or its insulation has been damaged. If there are any loose connections, we have to correct it. Open connections, terminals, rusting observed, we have to clean the terminal and reconnect the connections. Or if the rusting is too much or if the wire is damaged too much, then we have to replace the wire harness. If any wire damage is observed, we have to replace the wire harness. That is the best thing to do for longevity. If there is any incorrect wiring, the connections, they need to reconnect it, because it may happen that someone else has attended the machine and he has not done a proper connection. We can easily identify rodent bite by the bite marks on the wires, and it's best to replace the wires, the entire wiring harness, if any such bite mark is found. So checking the belt tension, what we do is the usual thumb method. We push the belt inside with the thumb with a normal push force, and the belt should not deflect more than 12 mm or half inch. This is the normal thumb rule. Then we look for wear and tear of the belt, whether the belt's having any cracks in between, or maybe the fibers of the belt have cut and loosened up. Then the belt may slip and it may not transfer the motor torque to the washing drum, so we have to replace the belt. Then the defect with the pulsator, the hub of the pulsator where we screw down the pulsator to the gearbox, if that hub is broken, the pulsator will not rotate. If there is a crack in the pulsator, if the pulsator is not tightened properly, the bolt is loose, these are the kind of defects that we usually check the pulsator. Any crack, wear off or fitment issue found in the pulsator, we have to replace the pulsator. Any bend in the gearbox shaft, replace the mechanical assembly. Check whether the pulsator is properly tightened or secured to the gearbox. The pulsator securing screw is not loose, it's properly tightened. Then we come to the motor problem. The probable problems with the motor: input voltage is not correct, capacitor is faulty, or the motor is internally jammed. For checking the capacitor, we need a multimeter which can check the capacitance, and then we can directly check whether the capacitance that we measure on the multimeter is equal to the capacitance rating written on the capacitor. Otherwise, we may replace the capacitor. The second method by which we check the capacitor, if our multimeter does not have a capacitor testing range, that is, we check the resistance of the capacitor. The resistance of the capacitor, when both the leads of the capacitor are connected to the multimeter leads, initially it starts with a low resistance and then it ends when the capacitor is discharged after a few seconds, that is somewhere around 10K or 1 mega ohms. If we are continuously getting OL, open load, or continuously getting more than 1 mega ohm in the capacitor, that is, we don't see the charging and discharging cycle represented by the resistance, the change in resistance of the capacitor, then we know that the capacitor is open. Or if we get zero when we are checking the resistance of the capacitor between the two terminals, zero means both the terminals of the capacitor are internally shorted, so it's of no use, it has to be thrown. Similarly, an open capacitor is also of no use. A proper good capacitor will initially start with a low resistance, and in a few seconds it will stop at a very high resistance value. So we know that the capacitor is charging and discharging properly. Here is how it is shown, also with the help of a connection with a 9-volt battery. We charge the capacitor with a 9-volt battery and then read the voltage across the capacitor terminals. It shows 9 volt, and rapidly that 9 volt will turn to 0 volts because the capacitor goes into a discharge mode. Then the capacitor is good. If initially it is not showing 9 volts, that means the capacitor is not charging it. Continuity method. If initially the capacitor shows continuity and then it stops, that is, the continuity it shows OL, that means the capacitor is good. If continuously it shows continuity, that means the capacitor is short, and it's not showing any continuity at all, the capacitor is open. Testing of the motor. The best way to test a motor is to test the winding resistance of the motor. Here we have got two windings, one is the clockwise and the other is the anti-clockwise or the counterclockwise. We check the winding of the resistance between the common terminal and the clockwise terminal, and the common terminal and the counterclockwise terminal. Both these windings are similar in nature, so both their resistance would be the same, and the resistance between the counterclockwise and clockwise terminals should be a total of the resistance of both these windings. Then the motor is okay. Then we can check the motor, the hot method, by giving supply between common and counterclockwise, and then common and counterclockwise, and common and clockwise. The motor has to rotate in clockwise or counterclockwise depending upon which two terminals are given 230 volt AC supply. Then at the end we check whether the PCB is defective We diagnose the PCB according to testing method given in one of our PCB testing tutorials, serial number WM2008CT0031, which is available in the Godrej training material archives. We can refer to the testing of the PCB from that training tutorial, and if we check the PCB as per that tutorial and if it is found faulty, then we have to replace the PCB. Here the diagnosis of the defective PCB is shown.
ये हमने 8 पिन कनेक्टर यहाँ से निकाल दिया है। तो यहाँ पे ये एक येलो और ब्लू एंड वाइट जो वायर है ये लीड स्विच की है, और दूसरी वाली येलो ये भी लीड स्विच और सेफ्टी स्विच आती है। और
The yellow and blue plus white, it goes to the lead switch. Yellow terminal is basically the supply voltage of 5 volts DC.
ये जो ब्लैक एंड ब्राउन जो है ये वाटर लेवल सेंसर की हैं।
Yellow, black and brown at the top, these three are a set which goes to the water level sensor.
तो अभी हम यहाँ पे वोल्टेज चेक करेंगे। तो पहले हम लीड स्विच वाले पॉइंट पे वोल्टेज चेक करेंगे। तो यहाँ
Third from the top,
4.9
both the
वोल्ट
terminals when we
मिल
check,
रहा है।
we should get somewhere
अब
around 5
हम
volts.
सेफ्टी स्विच जो है उसकी वायर चेक करते हैं। तो सेफ्टी स्विच की दोनों येलो वायर के अंदर कनेक्ट करके वोल्टेज चेक करेंगे। तो यहाँ पे भी हमें 4.9 वोल्ट मिल रहा है। तो ये जब हमने कनेक्टर निकाला हुआ है तब ये हमें
When we remove the connector and check directly on the PCB for the safety switch as well as for the door switch terminals, we should get 5 volts DC generated from the PCB.
वोल्टेजेस मिल रहे हैं। अब हम इस कनेक्टर को यहाँ पे लगा देते हैं और उसके बाद वोल्टेज चेक करेंगे। अब वाटर लेवल सेफ जो लीड स्विच है यहाँ पे वोल्टेज चेक करते हैं। तो अभी हमें यहाँ कोई भी
When we checked after removing the connector directly on the PCB, we got 5 volts. But on the same two terminals, when we are checking after connecting the connector, then we should get 0 volts.
नहीं मिल रहा है। और अगर हम सेफ्टी स्विच की चेक करेंगे दोनों येलो वायर के अंदर, तो यहाँ पे भी कोई वोल्टेज
Similarly, we do it for the safety switch
इसका
also.
मतलब ये है कि इस कनेक्टर पे जब हम वोल्टेज चेक करेंगे तो ये कनेक्टर निकाल के वोल्टेज हमें मिलेंगे।
So whenever we have to check whether the PCB is giving 5 volt DC to the lead switch as well as the safety switch and the water level sensor, while checking it, we have to remove this connector and check. Otherwise, we will get 0 volt DC.
ये हमने
Then we check the water level sensor and air hose. Check for the fitment of the water level sensor. Check whether the air hose is dislocated or it is loose, it is broken, it is cut. This is the location of the water level sensor shown in the diagram. When we remove the back panel of the machine, we get the location of the water level sensor. For checking the water level sensor, between brown and yellow wire, we have to check the frequency in kilohertz that these wires are generating when the water level goes up or down in the tub. An empty tap will show somewhere around 25 kilohertz and a full tub will show somewhere around 21.5 kilohertz. So this is the check for whether the water level sensor is responding to change in water level inside the tub. The water level sensor will give a different frequency for an empty tub, low level, medium, minimum and high. So we can see the working of the water level sensor and the frequency it generates in this video.
जैसे जैसे पानी का लेवल बढ़ता है तो फ्रीक्वेंसी इसकी कम होती है। पानी का लेवल अब रखा हुआ है हाई पे।
When the water level reaches the high level, the frequency will keep on decreasing, and for different models it will stop at 21.5 or 22.5, or in some models even near 19 kilohertz. The visual inspection of the water level sensor terminals will show whether there is rusting or whether there are any carbon deposits on the wires or the connections, which will show that even though there is a 5-volt voltage which is given to the water level sensor, still it's not responding because the wires are either rusted or they are cut. Then we check the air hose connection at the bottom of the tub as well as at the water level sensor end. At both the ends, the air hose connection should be fully tight, and also the clips should be tightly secured. The next area where we check for is the mechanical assembly. The mechanical assembly of the washing machine, which is also called the gearbox. If it is jammed because of any mechanical jamming or rusting, then also the wash will not happen even though the motor will try to run. So we have to visually check whether there is any leakage of lubricants, or whether there is any rusting, or whether there is any jamming of its various gears and the pulley. We can check by rotating it by hand whether it is freely rotating or whether it's jammed. In this video, we can do some of the checks. Rotating it by hand to check whether the shaft is rotating properly or not. Check for the clutch lever. When we disengage the clutch lever, it has to rotate with a higher RPM. This is for different models. When the clutch lever is engaged, the end shaft will move slowly. When it is disengaged, it will move at a faster RPM. Also, we check the engaging pin or the engaging dog, as we call it, whether it is broken or whether the engaging gear has got any broken teeth. These are the various visuals that we check for on the gearbox. Then whether the inlet valve is defective or blocked, how do we check it? We can directly give 230 volts to the inlet valve and check, or through the machine, if we give 230 volts, the valve should open. Connect it to the water level, connect it to with a hose to the water connection, and directly give 230 volts and check whether the valve is opening with 230 volts or not. or through the machine, if we give 230 volts, we should see that the water is coming out from the other end of the water intake valve. So these are the checks that we check. And also, if the water is not coming in, we can check whether there is a clog. This is how we check the inlet voltage between the two terminals of the inlet valve. And then to see whether the inlet valve is healthy or not, what we do is we check the resistance of the inlet valve coil. Inlet valve resistance in various models, it differs between 5.3 kilo ohms and 4.6 kilo ohms. For various models, there are various resistances we see between 4 to 5 kilo ohms of resistance of the solenoid coil. Then we check for clogging of the inlet valve filter. Usually when the incoming water is dirty, it carries a lot of biological material as well as dirt and stones, sand, etc. These are trapped in the inlet valve filter and it will not allow these contaminants to pass through. So we check the inlet valve for clogging, and if it is clogged, we can easily remove it, pull it out and clean it and fit it back again. Then for checking whether the heater or sensor are defective, we first check the heater wiring, whether the phase and neutral wires both are connected to the heater, or are they loose, or are they disconnected. And even when the wire is connected, are we getting phase and neutral, or whether it is heater is body short or heater is ground. If the heater is grounded, then also the machine would not work. So we have to check the connectivity between the heater terminal and the earth point of the heater. There should be no connectivity between the earth point of the heater and the heater terminal's phase or neutral. Then we check the heater itself, whether it is open or not. We check the resistance of the heater. For top load washing machine, the resistance of the heater is 35.8 roughly kilo ohms, ohms, not kilo ohms, sorry, it's ohms. And for front loading washing machine, the heater resistance is roughly 30 ohms. And then we check the sensor, NTC sensor. The NTC sensor is a sensor whose resistance increases when the temperature decreases and whose resistance decreases when the temperature increases. So the resistance of the NTC sensor acts inversely with respect to temperature. In the next slide, we can see the resistance and temperature chart for NTC sensor. This is the resistance and temperature chart for various ambient resistances. At ambient temperatures, we can check the resistance, corresponding resistance with the multimeter, and check whether the NTC sensor is working properly or not. This is how we check the heater and the resistance of the sensor.
इस वीडियो में हम वॉशिंग मशीन के हीटर को कैसे टेस्ट करेंगे ये देखते हैं। सबसे पहले अपने मल्टीमीटर को रेजिस्टेंस मोड में यानी ओम्स मोड में लाएं और हीटर के दोनों टर्मिनल पर रेजिस्टेंस चेक करें। उसी के साथ जो एनटीसी है उस एनटीसी पर भी हम रेजिस्टेंस चेक। हीटर का रेजिस्टेंस टेस्ट होने के बाद हमें एक और टेस्ट करना है जिसे हम बॉडी शॉर्ट या बॉडी अर्थ कहते हैं।
First we check the heater resistance, then the resistance of the NTC sensor, and then we check the continuity of both the heater terminals with the body of the heater or with the ground.
तो पहले दोनों टर्मिनल कहीं ओपन तो नहीं है ये चेक किया जाएगा।
It is not open because both the heater terminals are showing continuity.
का बॉडी के साथ
Now we check
चेक की
the
जाती है।
continuity, that there is continuity of each terminal with the body of the heater.
शॉर्ट बॉडी शॉर्ट है और खराब है।
If there are any input voltage and earthing problems because of this, the washing machine is not functioning at the customer's home, we have to check the input socket, 3-pin socket of the customer, check whether there is any earth fault or weak neutral, or whether the voltage is fluctuating, or whether there is too low voltage or too high voltage. If any such kind of unnormal conditions is found, then we have to ask the customer to either install a stabilizer or correct their main input socket. So these are the various checks that we do on the washing machine when customer complains that the washing machine's wash is not happening. Thank you friends, see you again with another diagnosis. Till time, goodbye.